So in this video, we are going to study about the schedule. Okay, what is schedule? A series of operation from one transaction to another transaction is known as schedule. Uh, Operation which is for a particular time, this transaction will be executed, and in another particular time, this a schedule. It is a schedule. Okay, this schedule it is of three types: serial schedule, non-serial schedule, serializable schedule. First, we can study about the serial schedule. Okay, what is serial schedule? In the serial schedule, it is a type of schedule where one transaction is executed completely before starting another transaction. Okay, so see here. We have two examples, schedule A and schedule B. There are two schedules. Okay, so here it is having two transactions, T1 and T2. So once the T1 transaction is completed, then only the T2 transaction starts in a particular time. Now again, we are seeing in the schedule B, there are two transactions. First, the T1 transaction is executed. Okay, it is happening first. After completion of the T2 transaction, then only the T1's transaction starts. So this is serial scheduling concurrently without interleaved. Okay, so it is happening concurrently in a serial way. So non-serial schedule. What is non-serial schedule? So here, non-serial schedule means if interleaving of operation is allowed. So interleaving of operation, see, allowed, then there will be non-serial schedule. See, for example, again there is given two schedules, schedule C and schedule D. So in schedule T, see, there are two transactions, T1 and T2. See, this two transaction is happening. Transaction 1, here these two instructions are executed first. After that, the T2 is coming. So there is no concurrent transaction, no serial transaction. So this type of transaction, interleaving operations are allowed between the transaction. This is called as the non-serial schedule. What is serializability? What is serializable schedule? So serializable schedule, it is used to find non-serial schedule. Okay, and it allows the transaction to execute concurrently without interfering with each other. That is called as the serializable schedule. Okay, then it identifies which schedules are correct when execution of the transaction. How we can say that the schedules are correct? Okay, how we can say, even though it is a non-serial schedule, will be serializable if its result is equal to the results of its transaction executed serially. If the results are equal for both the transaction, then it is said to be serializable schedule. Okay, it serializes that. So how we are going to test for a serializable? Okay, serializable, it uses graph to test the serializability of the schedule. Okay, so it uses precedence graph to test the serializability. Okay, so there is a graph pair. G is equal to the graph. V consists of set of vertices, and E consists of set of edges. The set of vertices is used to contain all the transaction participating in the schedule. Okay, the set of edges is used to contain all edges. So the edges helps to find the dependencies. Okay. So there are three conditions for testing serializability. There are three conditions. First, create a node Ti. Ti, that is Tj depends on Ti. Like functional dependence, we studied the same thing. If Ti executes write, if Ti execute writes before Tj executes Q. Okay, so this is the first condition. Then second one, create a node Tj if Ta executes read before Tj executes write. The next one, if Ti executes write before Tj executes write. So these are the three conditions for testing serializability. that I will explain you with an example. So this is the precedence graph of schedule S. If the precedence graph contains single edge Ti tends to Tj, then all the instructions of Ti are executed before the first instruction of Tj is executed. So first this must be executed. All the instructions of Ti must be executed first. If a precedence graph for schedule S contains a cycle, okay, if it contains a cycle, then S is non-serializable. If the precedence graph has no cycle, S is also known as serializable. Okay, you have to note these things. So when we study this with an example, see, this is the, from this diagram itself you can know it is a non-serialized schedule. Okay, non-serial schedule, because interleaved operations are allowed here, so it is a non-serialized schedule. So when we see the um, first set of instructions, that is T1 is also executing read A. Read A, it can be read operation can be done at any time. Okay, so read A. So see here. So read A. Explanation is given in T1. No subsequent write to A. So there is no subsequent write to A is there. Okay, so there we no need to form a new edge. Okay, so here the particular T2, the read B is executed. It also does not have subsequent write to B, so it no need to add new edges. Then in transaction T3, read C is executed. Here also no subsequent write to C, so there is no new edges to form. Okay, now when we see the again the transaction two things are executed, that is first write and write B, then only read operation should be performed. Okay, so first write, then next read. So this read B depends on the write B. Here see, read B in the that also in the third transaction, read B. So this read B, it is depending on the write B in the second transaction. So we have to add B is subsequently read by T3. Okay, so this B is subsequently read by T3. So there should be edge added, that is T2 tends to T3, that is T3 it depends on T2. Listen here, this is very important. T3, transaction T3 is depending on T2. Okay, again here, when we take the write C operation, okay, write C, the write C, after executing the write C, this C is used by, it is the T1, transaction T1 uses the C for read. Okay, read C. So here in the C, write C, C is subsequently read by T1. This C, this write C is subsequently the C, not write, the C variable, the C, it is subsequently used by the T1. So we must add an edge here. So T3, T1 depends on T3. T1 depends on T3. Okay, again, so when we take the transaction 1, it writes A, the A is subsequently used by the transaction 2 read operation. Okay, so A is used by T2, read A, that is in T2. So what we can say here, the T2 transaction, the A depends on here, okay, T1. So T1 tends to T2. T1 tends to T2. So so this is the cycle for serialization. The precedence graph for the schedule S1 contains a cycle. Okay, so it is depending on, see, we saw what T2, it is depending on T3. T3 is depending on T2. Again, T1 is depending on T3. Again, which one is depending? T1 is depending on T2. Did you understand? So there is a cycle is formed. So if a cycle formed here, we studied already. If a cycle is there, if the precedence graph for schedule is contains a cycle, then the S is non-serializable. Okay, non-serializable. If the precedence graph has no cycle, then S is a serializable. Okay, so this is the thing about the serial testing of serializability. So here also the same example. Here also you can see the first transaction, everything is read. See, T4, it reads A, T5, transaction T5 reads B. So read, it can occur anytime here. Okay. After this initial read, this is initial read. Okay. Here no problem. So it no need any edges. So next we have to see the next read. Okay. So read, 1 minute. So when we see here, the right A, see, right A, T4 for right A, this A is used where? In here, T5, read A. So, which is depending on this one. So, T5 is depending on T4. Okay, T5 is depending. So, likewise, as we saw the first example, the same thing here also you have to do and find the this one. Which transaction is depending on which one, and we have to check whether it forms a precedence graph, that is cycle. Okay, precedence graph for schedule 2 contains cycle or not, we have to find that out. Okay, if there is no cycle, then it is a serializable. Okay, there are types of serializability. There are two types: conflict serializable schedule and view serializable schedule. Okay, these two are very important. So conflict. Okay, there should not be any conflict in the schedule. Okay, schedule is called conflict serializability if after swapping of non-conflicting operation, it can transform it into. So how a conflict serializability can be converted to serial schedule? Okay, conflict should not be there in a scheduling. Okay, so that can conflict after swapping, it is formed to non-conflict and it is transformed to a serial schedule. You know, serial schedule. What is serial schedule? After a transaction is completed, then other transaction starts. That is serial schedule. The schedule will be a conflict serial if the conflict equivalent to a serial schedule. Okay. So for conflicting, there are